Good morning, Lancers. Today in Algebra 1, we are going to be working on some word problems that go along with our functions unit. So if you will turn with me to page 13, I'm in your notes packet on page 13. Follow along with this video and we're going to get these word problems sorted out today. So example number 1, we have a mouse that is running 3 meters per second. And we have our function here. So anytime you see the word per, that typically indicates multiplication. So we are running at 3 meters per second. We're going to be modeling the distance in seconds, and it goes ahead and tells you that x is going to be seconds. And we know that to be true because our x-axis is always our independent variable, right? And so we know independent variable is typically time. So you want to think about, what are we modeling here? Well, if x is seconds, then we're really modeling the distance. How far is the mouse running? And that's in meters. All right, so why are there no negatives on this graph? Why do we not have negative x or negative y values? Well, if you think about it, x is seconds. So can we have negative time? No. Y is distance. Can we have a negative distance? No. So we cannot have negative distance or time. Okay, how many meters can a mouse run in 2.5 seconds? So you want to think about, okay, is this an input or an output? 2.5 seconds. Seconds we know is our x variable. So I know that if this is an x, then it must be an input value. So I'm going to input that into my equation here and solve. And I have that y equals 7.5. Make sure you label because it's asking for meters. So the answer here is 7.5 meters. So we can go ahead and start to graph this. For every second, he's going to run 3 meters. So 1, 2 goes to 6, 3 goes to 9. So I have a graph here. And also you want to think about, is this going to be discrete or continuous? Well, if I'm modeling time, this is going to be continuous because time is continuous. So what does f of 0 represent? What is the 0? Well, since the 0 is inside my function, I know that this 0 must be an input value. So what this is asking me is, when is x 0? Well, x is 0 at time 0. So at time 0, the mouse has run 0 meters. All right, pretty good. All right, example number 2. Fastest recorded Hawaiian lava flow moved at an average speed of 6 miles per hour. So we have our function here. Again, seeing that per represented in multiplication. Describe the distance in y as the lava moved for every x hours. Okay, so how many miles did the lava move after 5.5 hours? So you need to think about, okay, is this an input or an output? And it told me that x is hours, so this must be an input value. So I'm going to input it into my equation. And I can conclude that y equals 33 miles. So that's how far that lava has traveled. So give 2 examples of inputs that would not be possible for this situation. So what kind of x values would not be possible? Well, if I know that my x has to be time, then I can't have negative time. So we could put any negative number. Then give 2 examples of outputs that would not be possible. So my outputs would be y. So what type of y values would not be possible? Well, I want to take into consideration my function, right? So the lowest value that I could have would be 0. All of my distance, I have to have positive distance as well. So we could also have any negative number here. Okay. Number 3, a local grocery store will pay you $7.50 per hour for to bag groceries. The maximum number of hours that they will allow you to work is 8. Okay, so they want us to sketch a function, and we've got to figure out what's our x and y axis, right? Because every good graph has labels. Labels, labels, labels. So we need to think about what's going to be our independent and dependent variable here. Well, the amount of money you get paid depends on how many hours you worked, right? So hours is going to be the independent, it's going to be the unchanging variable, and then the variable that does change is going to be the money earned. Make that look more like money. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8. And we're told we get $7.50 per hour. So write the x and y intercepts as ordered pairs. So what does intercept mean? If we think about football, we've been watching a lot of Chiefs lately in my house. If the football players have an interception, it means, the other team has interceded and taken a pass from the other team, right? So when we talk about x and y intercepts, it means they are intersecting. So we want to know what's the significance of being on the x or the y axis. Okay, so let's think this through. If x equals 0, x is time. So if I work 0 hours at the grocery store, then y would be 0, right? Nothing worked, nothing earned. So what do these represent in the problem? If I don't work, then I won't earn any money. Okay, so then let's think about this. What does the ordered pair 322.5 represent? Well, 3 is my input. That's my x. 22.5 is an output value. So input we know is x, so we can refer back to the graph, and this must be the hours worked. Whereas our output must be the money earned. So we need to add that to our graph here. So for 1 hour I get paid $7.50, and then 2 hours would be 15, and then 2 hours would be, or 3 hours would be $22.50. And I'm going to go ahead and make this continuous because you could argue that you could clock out or you could work part of an hour. So if you work for part of an hour, your employer is still going to pay you. So I'm going to argue that this would be a continuous graph rather than a discrete. All right, looking good. Feel free to press pause at any time if you need to take a minute, or press rewind and rewatch and take a second shot at it if you don't understand. Okay, next one, main event. Charges an entrance fee of $12 and an additional $1.50 for every game. So we need an equation, and we want to make sure we're practicing our function notation. Function notation being f of x. This is on your test, and your test is next week. So I really want to make sure that you're practicing this. F of x equals, I have to pay $12 to enter no matter what, and then I have to pay $1.50 for each game. So we know that to be multiplication. So I have to pay $1.50 times x. So the independent variable being the number of games I played, because the number of games we play is going to directly affect how much we have to pay to get in, right? So this is going to be, we'll just call these charges, I guess. Charges or fees or money spent. You know, you could put money spent. That would be a good way to do it too. Okay, so write the intercepts as ordered pairs. What do these represent in the context of the problem? So let's think about, this one's a little bit different. If x is 0, then that means no extra games were played, right? But don't I still have to pay just to get in? I have to pay $12 no matter what. So even if I pay, or even if I played 0 games, my y value would still have to be 12. So when we go over to our graph, even though I'm at 0, my intercept is going to be here at 12. So to write that as an ordered pair, the answer would be 0, 12. Okay, makes sense? So then for every game, if I have to play 1 game, then that goes up to $13.50. 2 games would be $15. And then this would be up to $18, and we can keep growing just like that. So would this be a discrete or continuous graph? I really want you to think about what we're modeling here. These are a number of games. Can you play like part of a game? Even if you just played part of the game, wouldn't main event charge you the full amount? So I would argue that this is going to be a discrete graph, because even if you only played part of that 4th game, you're still going to have to pay the full amount because main event wants their money. Okay, so how many games would you have to play if you spent 21 total? So this is different, 21 total. I want you to think, is this going to be an input or an output? And 21 is my charge, so I know that this has to be an output value, which means 21 goes in the y spot. So instead of f of x, I'm going to substitute a 21 because this is now my output. And we can solve for how many games we played. Write your answer as an ordered pair and then explain what it means. All right, so let's solve it. First thing we need to do is subtract 12. And so we have 9 here. And then divide by 1.5. And we get x equals 6. But we want to make sure we write this as an ordered pair. So to answer the question appropriately, x is now 6. And what was my y value? You got to go back to the output. The output was 21. So we should have 621. So what does this mean? For 6 games played, we spent $21. Okay. All right, that one was a good one. I like that one. All right, number 5. Last one, and we will say rate of change for block day when I come back. So we've just got one more left. All right, your backyard pool holds 500 gallons of water. In the winter time, it drains 20 gallons per hour. So we're draining. So you want to think about, is your function going to be increasing or decreasing? Okay, does my pool start full or empty? Sketch the graph and label the axes. Okay, so I know that I'm starting with 500 gallons of water, and as time goes on, it's going to decrease. So the variable that's changing here is the number of gallons in my pool. And we are going to be graphing that against time, because I can see I've got gallons per hour. So I know that time goes on our x-axis. And like I said, 90% of the time, time is going to be your independent variable. All right, we need an equation. And every equation has to start with f of x equals. Again, in equation, the word comes from equal sign. So you make sure you have that. All right, we started with 500 and then we're draining. So what operation is this adding or subtracting if we're draining gallons? Hopefully you say subtraction. So we start with 500 and I'm going to subtract 20x because again we have per hour. Anytime you see that word per, you need to think multiplication. So I'm going to start way up here with 500. Again, because at time 0, what are my intercepts? At time 0, y equals 500. I'll just put equal. So when x equals 0, y is 500 because at the starting time, there are 500 gallons in the pool. Okay. All right, so let's sketch. So after 1 hour, if I subtract 20, then I would be at 480. After 2 hours, I'd be at 460. And 3 hours, 440. And then 420. And 400. And you get the gist, right? Now, is this going to be a discrete or continuous graph? Hopefully you say continuous because water is going to drain at a constant rate. So this is going to be a continuous graph. Because again, water is draining at a constant rate until we get to 0. So once all of the water has drained, how long will it take for that to occur? Where will I be on the x-axis? Well, we could solve for that. If I wanted my y value to be 0, it's supposed to be a 20x. If I wanted my y value to be 0, I could go ahead and solve for it. I could subtract 500 and then divide by 20, and x equals 25. So my other intercept, when x equals 25, y equals 0. So this is important because this is the total number of hours that it takes for the pool to drain. So I'm going to put 25 hours for pool to drain. All right, whew. There's a lot to these word problems. There's a lot to consider. Make sure you're reading the directions. What are the intercepts? What do they represent? These are plural, meaning more than one. And make sure we have all of our correct labels on there. And again, we said the main event example was going to be discrete because even if you play part of a game, main event is still going to want you to pay for it. So I'm going to add that onto our little sheet here that we have a discrete graph. All right, nice work. We're going to pick up with rate of change on block day when I come back. Thanks, guys, and I'll see you on Wednesday.